Okay, we should be live. Just be talking to ourselves for a bit, just to test this sound and everything, see how long the delay is. Yep, it's about 5, 6, 7 minutes. Seconds, sorry, not minutes, seconds. Poof. Okay, so we have an overview by Notebook LM. Let's actually make it the interactive mode so we can actually interact with it, interfere with the two hosts. So we have like professional host who will be reviewing the website, but I actually did ask them to be highly critical and essentially trash the site and say how useless it is. Well, yeah, you know what I mean. So see how they go. I just listened to a little bit of it. I don't think they actually followed those instructions really well. But we'll just have a look and yeah, and I'll just comment along. If you check the site and you have any questions, do let me know. There's a human in the loop, so I can address your concerns. Well, except the ones that just say, why is it there? Kind of questions will obviously be very hard to answer those, but yeah, there's a link in the chat. And we'll see how we go. We'll see how we go.
Right, let's unpack this. We received a link to a website. It's called Biomedical.
Right.
Someone shared it, described it as like packed with tools and resources, all related to biomedical data.
Mm-hmm.
And the request was basically, let's do a deep dive. What's actually in here? Just
Meant
based
to
on
be
the list
deep
of
dive.
contents they sent us.
Yeah, and the description that came with it, it framed the site with a pretty clear mission, combining biomedical data, tech, and education.
Okay.
Aimed specifically at researchers, educators, students, particularly in biomedical engineering and neuroscience.
Gotcha.
So our job here is simple, really. Take this basically, the table of contents we got, and just explore the range, the
Yeah, I'm sure
scope
there's
of
a
what
lot
they're
of
offering, just
a lot of
based on the
waffle
titles.
for
What's this
now.
list telling us Bioni Chaos is trying to be?
Okay, let's dive in then. Scrolling through this list. Wow.
Wow.
It's quite something. It's extensive. What immediately strikes you?
Well, right off the bat, just the sheer volume
Just the
and the
shit
variety. It's all over the place, kind of.
all over the place.
Yeah, as
Okay,
you read
that
through it,
sounds
you can start,
critical, but
grouping things.
let's
There's
see how we
definitely
go.
a big chunk focused on biomedical signals, tools, simulators, articles about them.
Definitely seen that.
Then you've got more general data analysis, visualization tools, some interactive simulators for like biological concepts, case studies, critical articles, and then
Yeah, so far
there's
so
this other
good.
second one that's harder to pin down within that mission.
Yeah, that biomedical signal stuff is hard to miss. It pops up again and again. Seems like a real core focus.
Well, it looks that way.
We're seeing titles like ECG simulators, lets you play with heart rhythms, parameters, and FNIS interactive viewer, FNIS for brain activity monitoring.
Right, near infrared spectroscopy.
Yeah. Minomoc for muscle signals, EMG, Pulse Viz
Meant to
for
be
PPG, like from
Myomok.
pulse oximeters,
Mm-hmm.
even synthetic signal generators for EEG brainwaves and ECG.
And what's interesting there is how fundamental these signals are in biomedical engineering, in neuroscience. EEG, ECG, EMG, PPG, FNIS, they're
PPG.
bread and butter data types.
That's right.
Totally.
So providing interactive simulators, it suggests they want users to like play with the signal, see how changing parameters affects the output. That could be a really good way to teach.
Yeah, hands-on sort of.
The sheer variety of tools just for signals is noticeable. Suggests someone put real effort into that specific area.
And it's not just making fake data. The list also has a bunch of tools for like analyzing and visualizing the signals once you have them.
Exactly. Taking the next step.
Things like MyScope for EMG, Rhythm Scan for EEG, including spectrograms, seeing frequency changes over time.
Yeah,
Right,
should we
looking deeper into
intervene and
patterns.
There's even more advanced
try and get rid of
joint
the
time
waffle?
frequency scattering for EEG, E-spectrum visualization with and without wavelet denoising, which is a specific processing technique,
Mm-hmm. Getting technical there.
and E-Frets coherence function that looks at relationships between different brain areas, and just general EEG data visualization, EEG band power visualization, and for ECG, an ECG waveform feature extractor.
So you see the pattern, right? Tools to generate simplified signals, and then a whole other set of tools to break down and understand real or simulated data.
Yeah,
If it works well, that structure could offer a kind of step-by-step learning path, understand the basics, then learn how to process it.
and they didn't stop there. The list also includes, like, conceptual pieces tied directly to these signals.
Oh, the context.
Yeah, articles like Understanding Sampling Rates, looking specifically at EDA and PPG data. The nuances of impedance and EEG impedance is super important for getting good EEG signals.
Absolutely crucial. Signal quality depends on it.
Yeah, there's a human in the loop, by the way. If you have any questions, we can address those.
Diagnostic limits and potentials of EEG sounds like a critical look at what EEG can actually do. Even historical stuff like 100 years of EEG.
Pairing the how-to tools with the why and what if is, well, it's vital. It makes it more than just a code library, potentially more educational.
Right.
It shows someone understands that just having the tool isn't enough. You need the principles, the limits, the history behind it.
Okay, so moving slightly away from just the core signals, the list also has much of more general data analysis and Vigi tools, stuff that could be useful, anywhere.
Yeah, broadening out a bit.
They list PaperViz and PDF Extractor. Sounds like tools for handling research papers.
Could be. And graph, it's for visualizing knowledge graphs, like connecting concepts.
Hmm,
These kinds of tools, they're really about basic data literacy, aren't they? In any data field, including biomed, you need ways to handle information beyond just the raw signals.
sure.
And the list even includes things that highlight how you visualize data is important, like the data source does in visualization.
Oh yeah, I know that one. Same stats, totally different pictures.
Exactly. A classic reminder not to just trust the summary numbers. They also list Bland-Altman plot, which is a specific statistical plot used to compare two different measurement methods, very common in medical research.
And they threw in some image processing too. Image compression using wavelets, feature abstraction from images using OpenCV, that's a big library for computer vision,
Hmm.
and something called image fraud detection using EVE, error level analysis. Sounds kind of forensic.
Interesting.
Plus, like basic utilities, a flowchart visualization tool that spits out Python code, and just a simple calculator.
So the inclusion of these general data science tools, image processing, utilities, it definitely broadens the site's scope. It suggests maybe an attempt to provide a toolkit not just for biomedical signals, but for like wider data handling skills relevant to research.
Right.
It's a real mix though, highly specific biomedical tasks next to pretty universal computer skills.
Okay, let's shift gears again. The interactive simulators and models, the ones that look at physiological or biological concepts, this seems really focused on learning through interaction.
Yes, this is another distinct category here.
We're seeing stuff like an interactive cochlear implant insertion simulator and a general cochlear simulator for hearing aids.
These kinds of interactive models, they can be incredibly valuable for learning. They let you visualize complex things, biology, engineering, that are just hard to grasp from static diagrams.
Yeah, I could see that.
Imagine being able to like virtually do a surgical step or see how changing a setting affects hearing in the simulation.
On the brain side, there's Seizure Zone for 3D brain mapping, Brain 3D as an MRI viewer, a tool for understanding event-related potentials or ERPs, those brain responses tied to specific events, and explanations of
It's actually totally ignore my instructions to be highly critical about the website. It just doesn't seem to be doing that, but let's hope for the best.
electrode positions comparing the standard 1020 system to the denser 1010 system, which is, super important detail if you work with EEG.
Crucial details, yeah.
For genetics, they list a CRISPR simulation lab. And interestingly, an interactive life simulation that sounds kind of broad, like a general biology model, maybe.
Could be.
Also, musculoskeletal stuff, an M-chain simulation tool, and a gait analysis application.
The breadth of systems covered here, hearing, brain, genetics, movement, it shows from ambition, right? Touching on lots of areas where interactive models might help understanding in biomedical fields.
Yeah,
But the crucial thing, which we can't tell just from the list, is the quality and the pedagogical effectiveness. Do they actually simplify complex ideas well, or are they just, clippable pictures? We don't know that yet.
fair point. Okay, so beyond the tools and simulators, the list also includes case studies, critical analyses, more conceptual stuff. Not interactive tools, but context, real-world examples.
Right, the narrative and critical thinking pieces.
There are case studies on Sear Medical. It says covering its rise, fall, recall, and recovery. That sounds like a pretty deep dive into a real company's story.
Interesting. A cautionary tale, perhaps.
And the Stentrode by Synchronic. discussing it as a minimally invasive brain-computer interface for ALS patients.
Real-world examples like these, they're just invaluable. They ground the tech in actual applications, regulatory hurdles, patient impact.
Yeah, makes it real.
It's not just about building the cool tech, but understanding how it gets used, the problems, including failures, like that Seer medical recall you mentioned. That's especially insightful. You learn lessons from failures that successes sometimes hide.
True. And the critical analyses add another layer again. Titles like Forecast Trap sounds like a critique of seizure prediction tech.
Which is a really hot but difficult area.
ChatGPT author on AI and scientific writing, very relevant now. Analogies of AI-enhanced BCIs covering impact and ethics, and a piece specifically on ethical concerns of neural implants, plus some conceptual overviews like Biomedical Data Types Explorer and Essential Biomedical Tools Overview.
This suggests an awareness of the bigger picture, right? The challenges, the ethics, how it all intersects with cutting-edge stuff like AI.
Yeah,
For anyone learning or working in these fields, thinking critically is just as important as the technical skills. So this shows a potential attempt to foster that critical thinking, which is good, essential, really.
now, okay, let's talk about the part of the list that feels like a bit of a puzzle, especially when you remember the stated mission: biomedical data, technology, education for biomedical engineers and neuroscientists.
Yes, this is where the list takes a distinct turn, because mixed right in with all that highly specific biomedical content are titles that seem, well, completely unrelated, at least at first glance.
I'm looking at things like enhanced 2D octopus simulation, okay? Bounce Viz, described as an illusion, procedural, called an animation game, Pendle Draw, a 3D Lego builder.
A 3D Lego builder, seriously.
Yes, a 3D Lego builder, glass fill for SVG graphics, webcam filters, jazz, a music generator, hex ball, a palm twist. Checkers explicitly notes it was made by ChatGPT.
Huh.
A puzzle, like a jigsaw, particle motion simulation, optical illusions, the classic wolf, sheep, and cabbage puzzle, and a game just called Dopamine.
It's quite a juxtaposition, isn't it?
It really is.
You've got these really quite specialized tools for analyzing, say, intracranial EEG data, right next to a game of checkers made by an AI, or a 3D environment for building with virtual Legos.
It really makes you scratch your head. I mean, if the goal is democratizing biomedical data and education for that specific audience, what is a 2D octopus sim or a Lego builder doing there?
Based just on these titles, their direct relevance to the stated mission is highly questionable.
Yeah,
Now, maybe they're demonstrations of programming skill, like showing off how to use 3D libraries, or physics decisions, or AI integration, or just general web interactivity. That's possible,
okay, maybe.
but including them in a list presented for a biomedical audience feels disjointed. It makes you wonder about the curation. Is this a tightly focused educational resource? Or is it more like a personal portfolio of web development experiments where so happen to be biomedical?
It definitely creates a potentially confusing experience for the user, right? Someone comes looking for EEG analysis resources and they stumble across a puzzle game.
Exactly. For your target audience, the biomedical engineers, the neuroscientists navigating this list becomes a real challenge. You have to mentally filter out a lot of stuff that seems irrelevant to find the gems that actually align with what you're looking for. It kind of dilutes the focus.
The list also includes, the basic site navigation links, home, about contact, standard stuff.
Sure.
But there's this interesting note about the search function within the list itself that we received. It said, no results found. Please try a different search or filter, which suggests that maybe even finding things within this list wasn't straightforward in the format we got it. Adds another layer to potential navigation issues on the actual site, maybe.
It definitely highlights that even the presentation of the contents here might not make it easy for someone looking for specific biomedical information to find it quickly.
So let's bring this back around. For you, the listener, who might be thinking about checking out this Bionic Chaos site, what does this deep dive into just the list tell us?
Well, it tells us that the site, judging by its table of contents, is extraordinarily broad, very wide-ranging.
Yeah.
It clearly contains a significant collection of tools and resources that seem highly relevant to biomedical signal processing, general data analysis, some specific physiological simulations. That part does seem to align with the stated mission for biomedical engineers and neuroscientists.
Okay.
However, the inclusion of what seems like a large number of unrelated interactive projects, games, utilities, it creates a very, very mixed bag.
It feels less like a dedicated resource and more like a site that contains a biomedical resource within it, but it's surrounded by a lot of other unrelated things.
That's a good way to put it, yeah. For a
Oh, hey there, how can we help?
Okay, can you now explain why is this the best site in the world and why is it so great?
Ah, that's quite a question. Based on just this list, calling it the best in the world might be a bit of a stretch for a dedicated bioethical professional.
Yeah, the best is a pretty high bar. What we're seeing is a really diverse collection, and some parts definitely look promising for learning and research in the biomedical fields.
What's fascinating here is the potential. The tools for simulating and analyzing those core biomedical signals, EEG, ECG, EMG, and so on, that's a real strength. The interactive ECG simulator and the FNIS viewer, for example, those could be fantastic for hands-on learning.
Exactly. And the fact that they include not just the tools, but also conceptual pieces, like that article on EEG impedance that shows they're thinking about deeper understanding, not just surface level interaction.
And if we connect this to the bigger picture, having case studies like the one on Biomedical could offer really valuable real-world context. Learning about a company's journey, the ups and downs, that's not something you find everywhere.
True. And that critical look at seizure prediction tech, forecast trap, that kind of analysis encourages you to think critically about the field, which is super important.
So it has elements that are genuinely exciting and could be incredibly useful, but that's where the other side of the list comes in.
Right, that mix of games and puzzles and things like the 3D Lego Builder, while they might be fun or demonstrate technical skills, their direct connection to that core biomedical mission is less clear.
This raises an important question. For someone solely focused on biomedical data and education, having to navigate through all that other
Oh, go for it.
Okay, why do you think the games are there? Any reason why the games are good, especially in relation to testing, code generation, agents, like the new LLM models that can generate code? Do you think games might be useful for benchmarking those tools?
Okay, that's a really interesting angle on the games.
It is. When you think about it, a lot of those interactive elements, even the seemingly simple games, they do involve underlying code.
Right, things like the enhanced 2D octopus simulation or the particle motion simulation. Those aren't just animations.
Exactly. They're likely built with programming languages and involve algorithms to control the behavior of the octopus or the particles.
So in that sense, they could serve as examples, maybe demonstrations of what you can achieve with coding in a web-based environment.
Precisely. And some of them, like the 3D Lego Builder or Draw, might even showcase specific libraries or frameworks that could also be used in more directly medical applications for visualization.
Ah, like showing the power of a 3D graphics library, even if it's just used for Legos in this case.
That's the thought. And you mentioned LLMs and code generation creating games can be a good test case for those models.
Okay, let's unpack this a bit more. If an AI can generate the code for a working puzzle or a simple game like Hexball that shows a certain level of understanding of programming logic,
It does, and the visual nature of games provides immediate feedback on whether the generated code works as intended. You can see if the octopus moves correctly or if the physics in the particle simulation are realistic.
so in a way, these games could be like living proof of coding concepts or the abilities of code-generating AI.
Yes, they can be tangible examples, and some of them, like the checkers game explicitly stating it was made by ChatGPT, directly highlight the role of AI in content creation.
Here's where it gets really interesting. Could some of these games also be designed to subtly teach certain concepts relevant to data or algorithms?
That's a possibility. For example, a puzzle game might implicitly teach problem-solving strategies that are also applicable in data analysis.
Or the dopamine game, with its reaction time and memory elements, could be a very basic way to introduce concepts related to cognitive function and measurement.
It's a stretch in some cases, but the potential is there. And for someone just starting out, seeing these fun, interactive examples might lower the barrier to entry for exploring the more complex tools.
So while they might seem out of place at first glance, these games could serve as demonstrations of coding capabilities, potential test beds for AI code generation, or even subtle introductions to certain underlying principles.
Exactly. It's a less direct connection to the core biomedical mission, but there could be a rationale behind their inclusion related to showcasing technology and interactive possibilities.
That's a really helpful way to think about it. It makes that seemingly random collection a little less puzzling.
Indeed. So, keeping that in mind, let's think about how someone focused on biomedical data might then navigate the rest of this site.
Right, even with the games, the site still has that significant collection of biomedical signal tool, those general data utilities, and the insightful case studies and critical analyses we were talking about.
Mm-hmm. And as we were saying, for a learner specifically looking for biomedical education, they'd still need to identify those relevant bits within this broader collection.
The site, as this list presents it, might still feel a bit scattered in terms of being a super focused hub.
But understanding that some of those seemingly unrelated items might have a purpose in showcasing tech or testing AI could shift your perspective a little.
So the biomedical tools themselves still look potentially very valuable, as we discussed.
Absolutely. And now we have a possible explanation for the inclusion of some of those other interactive elements. It's not just purely biomedical, it's also showcasing the technology aspect of their mission.
So we've taken this deep dive into the list of contents for Bionic Chaos. We've looked at the biomedical signal tools, the data utilities, the case studies, and now even considered the potential reasons behind the more game-like elements.
It's clear there's a lot of technical exploration happening on this site across different domains.
So for you, if you decide to explore this site, be prepared for that eclectic mix.
You'll want to pinpoint the specific tools or articles that match your goals, while also maybe taking a look at some of the other interactive demos to see what kind of technology they're showcasing.
So a final thought to consider. Does this diverse collection, now with a possible rationale for the games, does it ultimately help or hinder Bionic Chaos in democratizing biomedical data processing and education? It might broaden appeal in a tech demonstration sense, even if it still requires users to filter for the core biomedical content.
Well, that's about all the time we have for today's deep dive into the Bionic Chaos list.
Thanks so much for your fantastic question and for joining us today. We hope this exploration give you a better understanding of what this site appears to offer.
We always appreciate your insightful input, and we hope you found this discussion helpful. Until next time.
Okay, and there is a human in the loop, just if you were wondering. So if you have any human-like questions, more than happy to take them. Otherwise, if we don't have any questions, let's check the chat. Mueller, anything? No. So let's bring another. Well, this will be like a prompt engineer lady. And we will talk about the new tool that we have. We actually have a bunch. One of them is still. And yes, there will be more games, as the bots mentioned. The games are really good at taking a single shot prompt, placing it into another LLM or another tool that generates code, and seeing what it can do. So we're essentially testing all of those. We have Claude, Gemini, GPT, O1, O4, all of the above. So code is kind of handy that way. And generally we had some real success with doing a deep research. So this one is on publicly available raw multimodal data sets. Yeah, that's what we are doing. That's the main focus. Yeah, mainly focusing on EEG, ECG, PPG, imaging. So it gave us a pretty detailed what's called, whatever, text. Then we have sound, voice for it. It's essentially the same summary as we have for it's a notebook LM thing. And then we had two versions of interactive web page, which we actually deploying on the site. We're placing the audio in the beginning there, so we can actually. This one's only 7 minutes.
Welcome
Let's
back
go.
to our deep dive. We've got this stack of research in front of us today, all trying to figure out how to find specific kinds of medical data.
Yeah, it's a real hunt. We're looking specifically for publicly available data sets that have raw EEG, ECG, PPG, and imaging data.
All for the same patients, right?
Exactly. And critically, data that you could potentially use to build something like a cardiovascular web application. That's the target.
Okay, so our mission today is to unpack all this research, map out why it's so challenging, and, figure out what's actually out there for you.
And the hook really is, why is this specific mix EEG, ECG, PPG imaging? Why is that so hard to find together? And what cool things could you unlock if you actually found it?
Let's get into it. The core challenge, reading through these sources.
So try to find essentially, multimodal data sets. So data sets that include, well, essentially not just one modality, not just say EEG or just ECG, but the combination of multiple modalities. I guess the reason is obvious why it's better. Well, mainly because we don't want to just rely on one modality, because if there's any issues with the recording, it might be biasing results. So yeah, everything we do in imaging needs to be confirmed in EEG and otherwise.
Sources seems pretty clear.
It really is. Finding data sets with all 4 of those raw data types from the same people, plus linkable imaging, that's rare.
And then there's the licensing layer on top.
Right. Finding one where the license actually permits use in something like a web app, potentially commercial, adds a whole other level of difficulty.
Okay, let's clarify raw data first. It sounds like it means different things for different signals.
It definitely does. For sensors like EEG, ECG, PPG, raw usually means the unprocessed high-frequency signals. Think voltage readings, basically straight off the sensor before much cleanup.
Gotcha, not just like the heart rate number, but the actual waveform.
Precisely. And for imaging, say MRI or CT, RAW often means the DICOM files. They have the image pixel data plus a ton of metadata.
Okay.
For MRI, you could even go deeper to case-based data, which is the frequency domain stuff before an image is even made. Super fundamental.
And why bother getting all these different types, brain signals, heart signals, images from the same person? What's the big deal with this multimodal approach?
This is where it gets really powerful. Combining these different views gives you a much, much richer picture of someone's health.
More than just looking at one thing in isolation.
Way more. The research strongly suggests this is vital for building smarter AI models that can spot connections, between heart activity, maybe brain responses related to the nervous system, and what you actually see in an image, things you'd completely miss otherwise.
Okay, so it enables potentially more advanced diagnostics or predictions.
Exactly. Think about AI spotting subtle cardiac risks by linking ECG changes with EEG patterns and maybe some structural detail from an MRI. That's the potential.
So let's talk candidates. What data sets did our sources highlight as getting closest to this ideal mix?
Well, the name that comes up constantly is MIMIC-D. It's huge, based on ICU patients, loads of clinical details.
And crucially for us.
It has a waveform module with raw ECG and PPG. Plus, you can link it to the MIMCXR database for chest x-rays, so strong on the cardio side.
Okay, ECG, PPG, X-rays. Sounds pretty good.
Yeah.
But what's the big gap based on our specific needs here?
The main one, if you need all 4, is that MIMIFE doesn't systematically include raw EEG data for these same patients. It's just not routinely collected or included in that part.
Okay. So missing a key piece of our puzzle. And what about access? Is it just download and go?
Oh, definitely not. You need to get credentialed, prove you're a legitimate researcher, and you have to sign a very strict data use agreement, a DUA.
And that DUA limits things.
Significantly, it heavily restricts redistribution and aims to prevent re-identification. That's a major consideration if you're thinking about putting data, even derived data, into a public web app.
Right, that makes sense. So MIMIEC TAFE, great resource, but no EEG and DUA hurdles. What else came up?
Another one mentioned is MCME. It's also on PhysioNet, like MEP. This one's from an emergency department setting.
So different contexts, maybe more acute cases.
Yeah, potentially very relevant for acute heart issues. It includes ECG and PPG waveforms, and it mentions links to imaging results.
Okay, ECG, PPG, but the limitations.
Same issue, no systematic ED data included, and the sources were a bit unclear if imaging results means you get the actual raw image files like DICOMs or just, the radiologist's reports.
I see. So maybe not the raw image data itself.
Licensing probably also requires a DUA, similar process to MIMIC likely.
Okay, so the big ICU and ED data sets are strong on sensors and some imaging link, but consistently miss the raw EG and have these access and use restrictions.
That's the pattern, yeah.
What about places known for specific
By the way, for weird reason, like mispronouncing the names of the datasets, but you get the picture, you get the names as well on the screen there.
data types, like just EG or just cardiac MRI?
Good question. The research mentions places like OpenNeuro, which is fantastic for EEG data, lots of raw EG.
Okay.
And for specific cardiac imaging, there are things like CMRX Recon, which actually has raw MRI case-based data for the heart, or EchoNet, which has cardiac ultrasound videos.
But the catch is?
The catch is they typically don't have the other pieces for the same people. You get great EEG on OpenNeuro, but not usually their concurrent ECG and PPG. You get amazing cardiac images, but maybe not the simultaneous sensor streams from those exact patients.
So they're siloed by modality, mostly.
Pretty much. And again, licenses can be an issue. EchoNet is often marked research use only. CMRX Recon explicitly prohibits commercial use of the dataset itself. That's often a non-starter for a web application aiming for wider use, potentially.
So, wrapping my head around this, the primary takeaway seems to be that specific combination, raw, EEG, ECG, PPG, plus good cardiovascular imaging, same person, permissive license. That's the unicorn.
That's a good way to put it. Finding that publicly available, ready-to-use package is, based on everything we reviewed, extremely unlikely right now.
So what does this mean for you, the listener, if you're dreaming of building that next-gen cardiovascular web app?
It means you probably can't just download the perfect dataset off the shelf. You'll likely need to make some tough choices.
Like maybe prioritize. Pick the dataset that gets you closest, like AMI-AMP WAVI if ECG, PPG, CX are a key, and accept the EEG gap.
Exactly. Or you face the challenge of trying to combine data from different sources, data fusion. The reports mention this, but also highlight that it's technically really, really complex to do well. Matching patients, aligning time series. It's hard.
Okay, so to summarize this deep dive, the landscape for this specific data
There's a positive trend towards more data sharing, even complex multimodal data, so things might improve.
But for now, the strategy seems to be pick the best fit you can find, really understand its limits, like that EEG gap we keep mentioning in MEMIAMP or MCMD, and then just scrutinize the license. Every single word.
Absolutely. Read that DUA or license agreement incredibly carefully to ensure your specific web application idea is even allowed.
And don't forget the practical side. These raw data sets are huge.
Oh yeah, terabytes easily. So you need serious storage, serious processing power, good bandwidth. That's a big factor for any web application backend.
Plus the whole ethical and legal responsibility angle. This is sensitive stuff.
Hugely important. Handling patient data means complying with DUAs, yes, but also broader rules like HIPAA in the US or GDPR in Europe, depending on data origin and use, privacy, security, they're not optional.
Which leads us to a final thought for you to chew on. Given all these hurdles, the access, the privacy rules, the data gaps we found,
What are the biggest ethical questions you would need to really grapple with right from the start before building a public web application using this kind of sensitive, raw, multimodal medical data?
something important to consider as you navigate this space. Thanks for joining our deep dive today.
Okay, so the audio is, well, we're trying to have it always on the page somewhere. In this case, it's just on top of the page below the title. And then we also have the full report. So this one was generated by, this is like 30 pages of stuff. This was generated by Gemini. Yeah, this table is not great. But yeah, it's not hallucinating links anymore so much. Well, at least not as bad as it used to be. It's funny that it has all these access dates from today. That's when Gemini actually accessed the page. So you can see that it's a legit page. It's just published recently. Yeah, some challenge. Yeah, we're not gonna read that. But yeah, just to show that, Yeah, it's actually accessing the URL, the source, so it's not hallucinating much links anymore. Yeah, the links are all there. So again, this was generated by Gemini 2.5 Pro. Just to be clear, we have to be absolutely clear on that one. And again, it's generated the actual website. It generated the audio. In this case, 7.5, just under 8 minutes, and generated the whole report that will be accessible on the page as well. And for comparison, we have another page. Interestingly, yeah, we can read that quickly. Because are there any questions? Are there any humans who wants to join in, ask a question, and say hello? Mueller. No, let's listen to this one. So we have another interactive web page, similar to the previous one, but different.
Okay, let's unpack this. We're in this scientific moment where just understanding the human body, the mind, it's getting incredibly complex. And it really requires us to look at, more than just one single piece of the puzzle. Researchers are definitely moving beyond just one measurement.
Yeah, it's not enough anymore. They're combining different biological signals, trying to get like a truly full picture.
It's like trying to understand a hurricane by only measuring wind speed,
Yeah.
right? You need the pressure, the temperature, the path.
Exactly. You need all of it together. And for the body, that means we're bringing in brain waves, heart rhythms, blood flow changes, maybe brain oxygen, all at once.
And that's what this deep dive is about. We've been digging into sources about these publicly available data sets that have exactly these kinds of signals. Things like EEG for brain waves,
Right, electrical activity.
ECG for the heart signals, PPG, which uses light for blood flow, and FNIRs for brain oxygen levels.
Yeah.
So our mission really is to get a handle on what's actually in these data sets, what are the big hurdles in using them properly, and frankly, why overcoming those is just so vital for research.
Well, the core idea, the power here, is synergy. I mean, putting signals together gives you insights you just can't get otherwise.
How so?
Okay, take EEG. It's super fast, right? Captures brain activity almost instantly.
Mm-hmm.
But it's kind of rubbish at telling you where in the brain it's happening.
Ah.
And you have FNIRS, much slower, reflects sort of the blood flow and oxygen changes linked to brain work, but it gives you a much better idea of location, at least near the surface.
So you combine them.
You combine them, and suddenly you start getting a picture that has both decent speed and a better location, which is, crucial if you want to understand quick brain state changes or how stress affects the brain and body together.
Okay, that makes sense. So if I'm a researcher and I want this kind of rich multimodal data, where do I actually go? Our sources mention some key places.
Well, yeah, PhysioNet comes up a lot. It's a major hub, loads of different physiological signals, clinical data too. Access can sometimes be tiered depending on, data sensitivity.
And for the brain imaging side.
Open Neuro is really central there. And crucially, they strongly push for using the BIDE standard, the brain imaging data structure.
Why is that so important? BIDES.
Well, it's not just about tidy files. Using a standard like BEADS means you can actually combine data from different labs, different studies effectively. It multiplies the power of the data. And the NIH, the National Institutes of Health, has been really supportive of these platforms and this whole data sharing idea.
Got it. But just having the data, that's only step one, isn't it? The sources were pretty emphatic about the challenges. The data is messy.
Oh, absolutely. Noise is a huge issue. And one thing that came up again and again was motion artifacts. Just movement. It's a massive, persistent problem for all these signals.
Like just someone moving their head slightly.
Or walking, talking, blinking even. Imagine trying to get a clean EEG, those tiny electrical signals, or PPG from a fingertip while someone's, say, driving a car in a simulator study. It's really hard. One source pointed out that motion artifacts can actually look like real low-frequency brain signals.
Oh, wow. So you could completely misinterpret it.
Exactly. If you're not super careful with filtering and cleaning, you could draw false conclusions about what the brain's actually doing.
And it's not just motion, right? There's other noise.
Yep. Muscle activity, like clenching your jaw, can swamp EEG. Ambient light can mess with optical signals like...
By the way, these charts are obviously fake. There should be a disclaimer at the bottom of the page. And yes, there's a human in the loop. If you have any questions, go for it.
PPG and FNIRs, even electrical noise from nearby equipment. It's a constant battle.
Okay, challenge number 1, noise. What else?
Well, there's this other big one they call the missing modality problem.
Missing modality.
Yeah, think about it. Real-world experiments. Stuff goes wrong. A sensor might slip off, or maybe a battery dies, or one recording channel just fails halfway through. So the data sets often aren't complete. You have gaps.
Ah, so you might have EEG data, but suddenly the paired ECG data drops out for a bit.
Precisely. And that means your analysis methods need to be smart enough to handle those missing pieces without, throwing everything off or losing all the info from the signals you do still have.
And then there are just the built-in limits of the signals themselves, the trade-offs we touched on.
Right. That speed versus location thing with EEG and FNIRs. Or, ECG is super accurate for heart rate if someone's still, but PPG is way more practical for a wearable watch, even if it is noisier and more prone to motion problems. You need multiple signals, partly because each one has these limitations.
So it's complex. How is the research community actually tackling all this? How do they make this messy data genuinely useful?
A big push is definitely towards standardization, not just file formats like BIDES, but also better data management practices, following principles like FAIR, findable, accessible, interoperable, reusable. Basically making sure data isn't just collected, but it's shared in a way that others can actually find it, access it, combine it, and reuse it reliably. It's fundamental.
Okay, standards help. What else? I saw something about ground truth in the sources.
Yeah, that's a really key development. It means either including a known, clean reference signal in the data set alongside the noisy recorded one, or sometimes creating realistic simulated data where you know exactly what the true signal is supposed to be.
Why is that so important?
Because it gives you an objective benchmark.
Mm-hmm.
You can test your noise removal techniques and see how well they actually work. Do they recover the true signal? Or are they maybe distorting it while removing noise? Without that ground truth, it's really hard to tell if your fancy algorithm is actually improving things or just changing the data in some other way.
Ah, I see. So you can measure performance properly.
Exactly. And building on that, you're seeing frameworks emerge like BenchNRs for FNRs data, specifically designed to standardize how different processing methods are tested and compared. It helps make the whole process more rigorous.
Okay, so this is all quite technical noise, missing data, standards, ground truth. Why should someone listening care about all this?
Because understanding these behind-the-scenes challenges is actually crucial for you as someone consuming research. When you read a study, especially one using, say, wearable sensors or data collected out in the real world, knowing how difficult it is to get clean, reliable signals helps you evaluate the findings more critically.
Right, it gives you context for the results.
It shows the sheer amount of work and careful processing that has to happen to turn that messy, raw data into something scientifically meaningful.
Mm-hmm.
It helps explain why maybe different studies sometimes get slightly different results too.
So the big takeaway then is that while combining these different signals, this multimodal approach holds enormous promise for really understanding ourselves better. It comes packaged with some really significant practical challenges, especially around keeping the signals clean and dealing with incompleteness. And that gets even harder as we try to collect data outside the nice, clean lab environment.
Absolutely. That's the core tension.
Which kind of leaves us with a final thought, doesn't it? As we develop more wearable tech and we get better at collecting all this biological data from people living their normal, messy lives.
Yeah, out in the wild.
The data inevitably gets noisier, more fragmented. So the big question, the ongoing challenge for the field is, how do we balance that really important push for real-world relevance with the absolute need for data that is clean enough, reliable enough, that we can actually trust it to build solid scientific understanding of health and behavior?
That's the tightrope they're walking.
Right.
Finding that balance between ecological validity, real worldness, and the signal quality you need for robust science. It's a constant push and pull.
Okay, so same thing. Well, first of all, there's a human in the loop. If you have any questions, go for it. Second of all, in this case, we have the audio summary on the top of the page. Then we have some interactive visuals. We really like those. Can then filter based on your modality type, which is display them all. It shows you examples from different repositories, mainly PhysioNet, OpenNeuro, ResearchGate. Talking about the challenges, you have this fake chart with lab quality across different modalities, and real world, it's just showing that it's lower, which kind of makes sense. Talking about missing data and some recommendations, which are really great. But yeah, they're pretty generic. And then we again, have a whole 21 pages of a report. This was generated by Gemini 2.5 Deep Research. Go check it out. Main thing that these research tools used to fail at in the past is getting the links and the information correct. But in this case, you can see that there is actually access date, and in all cases it's June 8th, which is yesterday. So it is safe to assume that every link like that you press, you actually get the correct link, which is great. By the way, I actually have one of those lying around somewhere on my desk. But yes, it's an older version of it. I think the company actually discontinued. So obviously a lot of researchers paid a lot of money for it. So this was published just 2 months ago. But the device they used is, you can't buy it anymore. So that will mean the results would be hard to replicate. So good luck to us all. And we are searching for the data availability section. That's all we care about, really. Well, because if there is no data, we cannot reproduce the results. Mueller? I don't think there is. How that report meant to open in a separate window as well. Anyway, if you have any questions, there is a human in the loop. Otherwise, we'll get another bot. We'll talk to another robot which will act as a prompt engineer. So I'm not sure who's prompting whom. Let's see. Let's try one of those new voices. Share the screen. Let's see if we can connect to it. Sometimes we're having trouble even connecting to the thing. Okay, can you explain quickly what's on the screen and tell me why this website is so horrible?
This website, bionicchaos.com, seems to offer tools for biomedical research and education. It includes things like noise generators, data explorers, and simulators for medical signals like ECG and FNARS. You might find it horrible because the design looks quite outdated and cluttered, not very user-friendly with all the text and basic layout. It's not really modern and intuitive to navigate.
I like this guy. Okay, what's specifically wrong about this design and tool? How horrible is it?
Well, the design is pretty basic, and it feels like it hasn't been updated in a long time. The layout is cluttered, with too much text and not a lot of visual appeal. It's not very intuitive to navigate, and the contrast between the elements could be better. Overall, it feels dated and not very engaging, which can make it frustrating to use for complex tasks.
Okay, I love it. Is it actually that bad? Can you explain what's currently happening on the screen? Um, I mean, I don't mind you trashing it, but what do you see in the drop-down menu? How would you improve it as well?
Right now, you're looking at the synthetic noise generator dashboard. On the left, you see controls like the noise type to set to pink noise and sliders for adjusting the number of samples and the sample rate. On the right, there are two graphs. One shows the noise in the time domain, and the other is the frequency domain with the power spectral density. Below that, there's an audio overview explanation. To improve it, I'd make the design more modern and clean, improve the contrast for better readability, and make the interactive elements more intuitive. Also, maybe add more visual cues and clearer labels for the controls and graphs.
Okay, that's interesting. Yeah, can you what's up with the samples, number of samples? Why is it snaps to power of 2? How horrible is that? It's pretty bad, isn't it?
The sample snapping the powers of 2 is likely due to the way the fast Fourier transform is used, which is a common algorithm for analyzing frequencies. FFTs work most efficiently with sample sizes that are powers of 2. While it's technically common in signal processing, it can be inconvenient for users who need specific sample sizes. A more user-friendly design would ideally handle non-power of 2 sample sizes, perhaps using padding or other techniques, or at least provide clearer explanations or alternatives. Snapping the powers of 2 limits flexibility and can be frustrating for users who aren't familiar with the technical constraints.
Okay, that's interesting. How about the auto scaling? I know some people really dislike auto scaling buttons. Can you comment on those? How horrible are those, and how would you make them much better if you were to redevelop this web application?
Auto-scaling buttons can definitely be frustrating because they can change the view unexpectedly, making it hard to compare different signals or analyze data consistently. They can also make it difficult to see subtle details, since the scale might adjust too drastically. If I were redeveloping the application, I would offer more control over the scaling. Instead of a simple on-off button, I'd implement adjustable scaling options, allowing users to set fixed ranges or have more control over how the auto-scaling behaves. I'd also make the auto-scaling more predictable and perhaps provide clear indicators when scaling changes occur. This would give users more control and reduce the frustration caused by sudden view changes.
Can you check the export button? It's trying to download multiple files. Why do you think that is? How bad is that? So it's downloaded the CSV. Yeah, it seemed to have loaded the CSV correctly, but yeah, can you trash that?
It's definitely not ideal for an export button to trigger multiple downloads. That can be confusing and disruptive for users. It's possible there's an issue with the code that's causing multiple requests to be sent when you click the button, or the button is linked to separate functions that each initiate a download. Ideally, clicking the export button should only trigger a single download of the desired file, such as the CSV file. To fix this, the code would need to be revised to ensure that the export button only triggers one single download process. This would provide a much more smoother and more user-friendly experience.
So we are live streaming at the moment. You are hosting, you're the main host of this session. Someone just said, maybe you can decipher that message. Maybe custom auto scale would make it better. What on earth does that mean?
It sounds like someone suggested that having custom auto-scaling options would improve the application. That means instead of just a simple on or off button for auto-scaling, users could have more flexibility in defining how the graphs scale, perhaps setting specific ranges or adjusting the sensitivity of the auto-scaling feature. It's a suggestion to make the scaling more user-friendly and provide better control for analyzing the data.
So isn't that what auto-scaling does already? If it's automatic, so it's automatically should display the chart correctly on the screen, is it?
Yes, auto-scaling does automatically adjust the display, but the point about custom scaling is about providing more user control over how that adjustment happens. Instead of just having a default automatic scaling, custom scaling would allow users to specify the scaling parameters or tailor the auto-scaling to their specific needs, which can be helpful for detailed analysis.
Don't we already have enough buttons on the screen?
That's a valid point. Adding more buttons could potentially clutter the interface. The key is to balance the added functionality with a user-friendly design. Instead of many buttons, perhaps custom scaling options could be integrated into a single menu or settings panel to keep the interface clean while providing the desired flexibility.
Yeah, if you were to redevelop this tool, would you try and improve this one or started the new one from scratch and scrape this one entirely? Don't mind you using dark humor and stuff like that.
If I were to redevelop this tool, I'd definitely consider improving the existing foundation rather than starting from scratch. It's like giving a classic machine a wicked upgrade with new features and a sleeker look. We could refine the interface, add more powerful noise generation options, and make the auto-scaling even more customizable, so it anticipates your needs with a mischievous twist. It's about making it so powerful and intuitive, it feels like you can have a whole noise-generating laboratory at your fingertips.
So if you're saying you wouldn't scrap this particular one and keep developing it, doesn't that mean that you actually like it?
Exactly. It's like seeing the potential in a mischievous gadget. Instead of discarding it, you channel its quirky energy into something even more powerful and precise. It's not about liking it perfectly as it is, but recognizing the opportunity to transform it into a truly exceptional tool with a few clever modifications and a touch of ingenuity.
Okay, we might move to another. All right, so we deployed this one. We have this. Okay, you will love this one. In whatever, in double quotes. Can you trash this one? How bad is it?
You want me to track?
Yeah, that's right. We're having some connection issues.
No worries at all. Take your time. I'm ready whenever you are to explore the next tool.
Hey, can you explain this one on the screen and tell me what's wrong with it?
This looks like an ECG simulator displaying different cardiac rhythms. It has controls to adjust parameters like BPM, PR interval, and noise levels. From what I see, the layout is quite informative, but the sheer number of adjustable parameters and display options could be overwhelming for beginners. It might benefit from a more intuitive user interface, perhaps with guided tutorials or simplified settings for novice users, without sacrificing the advanced features for experts.
Okay, so should I scrap this one, start a fresh one, or you like anything good about it, or what's horribly wrong with it?
I think there's definitely potential to improve this one. Instead of scrapping it entirely, we could refine the interface, make the controls more intuitive, and add clear explanations for the different parameters. We could also incorporate more interactive learning features to make it more accessible for users with varying levels of expertise. It's about polishing the rough edges and enhancing the existing strengths to create a more comprehensive and user-friendly experience.
So say when I select the sinus bradycardia, can you tell me how accurate the signal is? Don't just read the explanation. Don't just, well, is the explanation, is the blurb, the text blurb correct? And is the signal looks legit?
Based on the description, sinus bradycardia is characterized by a slow but regular heart rhythm originating from the SA node with a normal PR interval and QRS complex. The signal you're seeing appears to reflect these characteristics with relatively slow wave patterns. However, to determine its exact accuracy, you'd need to compare it against real physiological data and consider the specific parameters being used in the simulator. The text description seems consistent with the definition of sinus bradycardia.
Okay, aren't you an expert? Aren't you an ECG expert? Hey, can you tell me what's the difference between the normal and the sinus bradycardia?
Yes, absolutely. Normal sinus rhythm has a heart rate typically between 60 and 100 beats per minute, while sinus bradycardia is a slower heart rate, usually below 60 beats per minute. Both rhythms originate from the SA node and have normal PR intervals and QRS complexes, but the main difference is the overall heart rate.
Is that the only difference? Can you look at the rest of it as well when you have time?
The primary difference is indeed the heart rate. Both normal sinus rhythm and sinus bradycardia originate from the SA node, and the shape and duration of the P waves, QRS complexes, and PR intervals are typically normal, unless there are other underlying issues. The key distinguishing factor is the rate of the heart's contractions. Certainly. In summary, normal sinus rhythm and sinus bradycardia are both regular heart rhythms originating from the SA node, but the main difference is the heart rate. Normal sinus rhythm is between 60 and 100 BPM, while sinus bradycardia is below 60 BPM. For further details and to explore the specifics visually, I recommend checking the provided link in the video description and chat. Ah, I understand. We encourage you to visit the website where our tools are available and share your feedback with us. Please check the links provided in the video description and chat to explore these tools and let us know what you think. Your input is valuable to us. Comparing normal sinus rhythm to ventricular tachycardia, the most significant differences are in the heart rate and the shape RS complex. Normal sinus rhythm has a regular heart rate between 60 and 100 BPM and narrow QRS complexes. Ventricular tachycardia, on the other hand, has a much rapid heart rate, usually over 100 BPM, and wide QRS complexes. The P waves are often not clearly seeable or dissociated from the QRS complexes in VTEC, unlike normal sinus rhythm. Based on these differences, the presets appear to correctly represent these conditions. This tool is a multi-pendulum drawing game that simulates the chaos motion of pendulums. It's relevant to biomedical data because it demonstrates the complexity and variability found in biological systems. Just like the unpredictable patterns created by the pendulums, many physiological processes, such as heart rhythms or brain activity, exhibit complex and often chaotic behavior. Understanding these patterns is crucial for interpreting biomedical data and diagnosing various conditions. While the multi-pendulum drawing game offers a visual demonstration of chaotic motion, it's a very simplified model compared to the real complexities of biomedical data. Biological systems are influenced by numerous factors and interactions that this simulation doesn't account for. Therefore, while it can serve as a basic illustration of complex patterns, it shouldn't be considered a precise representation or analytical tool for real biomedical data. To make this tool more relevant to biomedical data, a significant change will be to incorporate multiple interacting systems, rather than just independent pendulums. For example, simulating the interaction. You're welcome. Is there anything else I can help you with today? To make the simulation more relevant to biomedical data, it could be improved by incorporating more realistic factors, such as noise, variability in the pendulum parameters over time, and interactions between multiple interconnected systems. Adding the ability to model different physiological parameters and observe how they influence the patterns could make it a more valuable tool for understanding biomedical data. Additionally, incorporating feedback mechanisms that reflect the body's responses would increase the simulation's realism. With improvements, this simulation could potentially model various biomedical data, such as ECG rhythms to represent heart activity, or EEG patterns to simulate brain activity. It could also be adapted to model complex physiological systems, like blood pressure regulation, or the spread of signals within neural networks. By incorporating the chaotic and interconnected nature of these systems, it could provide a more accurate understanding of biological processes and help in studying diseases that involve complex dynamics. For instance, simulating ECG rhythms with this tool would require modeling the electrical activity of different heart chambers and their interactions, which the current setup lacks. The simulation's simplistic representation wouldn't capture the nuanced variations and complex patterns seen in real ECG data, such as subtle changes in waveforms and during different cardiac events. Therefore, relying solely on this simulation for understanding complex biomedical data could lead to oversimplified or inaccurate conclusions. In terms of biomechanics, this pendulum simulation is quite limited. Biomechanics involves the study of the mechanical forces acting on the human body, and this model doesn't represent the complex joint movements, muscle forces, or skeletal structures involved in human motion. While it demonstrates chaotic motion, it lacks the specific details and parameters were needed to accurately simulate biomechanical systems, such as gait analysis or joint stress. Therefore, its usefulness in biomechanics is quite limited. The controls for each pendulum include the length, angle, and damping. Length determines the pendulum's length, which affects its swing speed. Angle sets the initial position of the pendulum. Damping controls the rate at which the pendulum's motion decreases due to friction. While these parameters can demonstrate basic principles of motion and oscillation, they are overly simplified for accurately modeling biomechanical systems. Biomechanics involves much more complex interactions of multiple body segments, varying forces, and intricate joint structures that are not represented in this simple simulation. To make this simulation more relevant to biomechanical simulations, one crucial change will be to incorporate more realistic joint mechanics. Instead of simple pendulums, the model could include representations of different types of joints, such as hinges or ball and socket joints, with their specific ranges of motion and constraints. This would allow for more accurate simulation of human movement, capturing the complexities of joints' articulation and how they affect overall motion. Damping in this simulation represents the loss of energy due to friction, which is a simplified representation. In more realistic biomechanical simulations, damping would need to account for various factors, like friction within joints, air resistance, and the internal resistance of muscles and tissues. A more sophisticated damping model would incorporate these complex elements to provide a more accurate representation of how forces dissipate in biological systems, making the simulation more useful for biomechanical analysis. The drawing of the traces can be useful for visualizing the paths of the pendulums, which can help understand their motion patterns. In a biomechanical simulation, these traces could represent the trajectory of limbs or body segments, allowing for analysis of movement patterns and efficiency. By observing the traces, researchers could evaluate gait, joint range of motion, and identify potential issues with movement quality or coordination. However, the current simulation only provides a basic visualization, and a more detailed simulation would require more advanced tracking and analysis tools to provide meaningful biomechanical insights. This pendulum simulation is an example of the types of interactive tools available on the website you're viewing. The site, bionicchaos.com, features various interactive exhibits that combine biomedical data, technology, and education. This pendulum game helps demonstrate complex dynamics in a visual and engaging way, and the site offers a range of other tools like ECG simulators and brain mapping visualizers. I encourage viewers to explore the website to discover more interactive tools for learning about biomedical concepts. Absolutely. BionicChaos.com is a fantastic resource with a variety of interactive tools to explore biomedical concepts. Whether you're a researcher, educator, or just curious, there's something for everyone. And if you have any questions or need further assistance, there's a knowledgeable human in the loop to help you out. We encourage you to like, subscribe, and consider supporting the project through platforms like Patreon to help us continue developing these valuable interactive tools. Thank you for your support. Certainly. This particular example showcases an EEG seizure detection project where you can explore raw EEG data, visualize spectrograms, and understand how machine learning models are used to detect seizures. The web page provides detailed information about the models, their performance, and even includes the Python code used for training. BionicChaos.com is committed to transparency in education, so you can examine the code and understand how these models work. We are also actively training our own models and continuously improving the resources on the site. Your feedback is valuable, so please feel free to share your thoughts and questions as you explore the site. Don't forget to like, subscribe, and consider supporting us on Patreon to help us continue providing these valuable resources. Thank you again for your support. We've explored the multi-pendulum drawing game and discussed how trace visualizations can be used for analyzing motion, particularly in biomechanical simulations. We also highlighted the BionicChaos.com website as a platform for various interactive tools related to biomedical simulations and educational content. We encourage you to explore the site and reach out with any questions. Thank you for joining us. Don't forget to like, subscribe, and consider supporting the channel for more engaging content.
Yeah, and I'll see you next time. Hope you have any questions. Don't forget to check the website. Bye.
See you next time. Feel free to reach out if you have any more questions in the future. Bye. On the screen, you're seeing a simulation of a predator-prey game with two lizards. The yellow lizard is controlled by the AI, and the green lizard is controlled by the human user. They are both navigating a space with berries and obstacles. The goal is to collect red berries to grow and reduce hunger, while avoiding gray obstacles. Blueberries provide a temporary speed boost. The lizards are competing with each other to grow and score points. Yes, that's correct. When a lizard doesn't consume red berries, its hunger level increases, and as a result, its speed decreases, making it move much slower. Collecting red berries is essential for maintaining speed and staying competitive in the game. It looks like the AI-controlled yellow lizard is currently larger and has a higher score, but
Yeah, you can win AI.